Okay, in this video, we are going to talk about solving quadratic inequalities. And there's going to be quite a bit of information in this. So we're going to talk both about solving by graphing, and then we're going to talk about solving quadratic inequalities using some algebra. And I want to talk about graphing first because when I go to the algebra, I'm going to think about the algebra in terms of a graph. So you'll see what I mean when I get there. I am going to assume that you have seen some things like factoring, completing the square, using the quadratic formula. I'll remind you of those, but it won't be a full in-depth conversation. Okay, so you've got this quadratic inequality here, and I'm going to look at this example here. Let's start with x squared plus 2x minus 3 greater than 0. So I was sitting with someone the other day. We were doing some math together, and she happened to have quadratic inequalities, and I said, what does this even mean? You know, when you see this x squared plus 2x minus 3 greater than 0, what does that mean? And she didn't have a good answer as to what this even was asking. So I thought, well, let's start there. So what does this even mean? When you get this inequality, what are we even trying to find? Okay, so let's start there, and then we'll actually talk about doing it. So this is going to be a little long-winded, but that's okay. Okay, so when I see this statement, x squared plus 2x minus 3 greater than 0, that says something to me. It's asking me to do something. And what is it asking me to do? Well, let's start off with an example. Okay, so we're going to pick any old value of x that we like. So I don't know. I'm going to pick some value of x. Let's pick one. I don't know. How about I pick x equals 10? Okay, so let's take that value and we're gonna do some arithmetic, right? I've got x squared plus 2x minus 3. Let's take that and let's plug in x equals 10 and see what it spits out. Okay, so we would have, well, 10 squared plus 2 times 10 minus 3. So I'm just substituting in x equals 10, x equals 10. There's nothing special about 10. I'm just picking a number to use as a specific example. So 10 squared, that's going to be 100. 2 times 10, that's 20. And then we subtract 3. So that's going to be 120 minus 3, which looks like 117. Okay, so at the end of the day, I got 117. Now, part 3 says I'm going to ask myself, that value I got out, is that value greater than 0? Because that's what this inequality refers to. It says, do you get out something that is greater than 0? If the answer is yes, we're going to keep that value of x, and that value of x goes in the solution set. So I now know I've got my solution set. Well, I don't know all of it. I've got my solution set, but I know for sure that this number 10 does go into it. It's going to belong to that solution set because I got the number 117, which is greater than 0. So x equals 10, that's a good number. I'm going to keep it. And if it hadn't been greater than 0, well, we just simply wouldn't include that number in the solution set. We would get rid of it. Okay, so step 4 says, hey, good job. We've checked one number, right? We happened to check the number x equals 10, and either that did or didn't satisfy the inequality. So what is the inequality saying to me? It's saying the following. It's saying, tell me, it says, hey, tell me all the numbers that do work. Tell me all values of x that satisfy that inequality. That's going to be the solution set. So somehow we have to figure out what numbers work and what numbers don't work. Well, we can't obviously test every number right? We couldn't test every number to see if it works. So again, when I see this inequality, for example, x squared plus 2x minus 3 greater than 0, it says, tell me all numbers so that when I do this arithmetic on the left with that number, I'll square it, I'll take 2 times the number, we'll do all the arithmetic. Tell me all those numbers so that when I do that arithmetic, I end up getting something greater than 0. Well, again, we can't check every value, so that's where we're either going to graph or to do some algebra to help us come up with our solution. Okay, so let's talk about graphing first. So let's talk about graphing in general. Okay, so this is not, okay, so this is this graph that I have here. This is not, oh my goodness, this is not, obviously not a quadratic. And I say obviously because I hope that you have seen quadratic functions. And again, they look like a parabola. They either open, let me make this look a little better. They either open up or they're going to open downwards. And we'll talk about that a little bit more here in a second. So this function's not a quadratic, but that's okay. We can still talk about it. So I've got the graph of some random function here, f of x. Let's talk about this notation for example. For a moment, excuse me. What does a graph even mean? So for example, I've got this dot on my graph, and it says that dot represents, that has the coordinates -4, 1. Well, again, that tells me something. It says whatever formula that goes with f of x, there's some formula that goes with f of x. I know it's not x squared plus 2x minus 3 because that makes a parabola. But there's some formula that goes with it, spits out that graph, whatever it is. It says if I take x equals -4, if I take x equals -4 and I put it into that formula and I do all the arithmetic, maybe it's complicated, maybe it's simple, it says at the end of the day, I get the number 1 out. That's why we put that dot there. We don't get to see all the gory details, right? We don't see all the arithmetic that happened. We just know that if we start with -4, it'll spit out 1 when it's done. Okay, fine. What that tells me is, the thing that I really want to point out is, notice that values on the graph that are above the x-axis, anywhere that graph is above the x-axis, it says you're getting a positive value out if you're above the x-axis. So for example, this little section of graph right here, that's above the x-axis. All of the y values through there, those are all positive numbers, again, because it's above the x-axis. And again, maybe I'm beating a dead horse here, as they say. But again, I like to think about things visually, and I am really kind of thinking about graphs, even when I'm doing the algebra. Let's think about this section of the graph, that's below. I've got a portion here that's below the x-axis, and then I have this little portion on the right that's also below the x-axis. Well, again, what it says is, it says you'll start with some x value. It says at the end of the day, you get some negative y value out. We get some negative number out. And that's what the graph tells us if we're below the x-axis. It says all of the values that we're getting out, all of the outputs are negative. Okay, and then, well, what happens exactly along the x-axis? Well, right where you hit the x-axis, that's where you're getting an output of 0. That's where the output would be equal to 0. So again, as they say, a graph is worth, a picture is worth 1,000 words. So a graph is worth 1,000 words. So my point is, we can now read off the solution. Suppose I have, I've got some inequality, and they say, hey, where is that inequality greater than, or in this first one, where is it greater than or equal to 0? I'm going to use interval notation. Well, okay, I said the part of the graph that's greater than or equal, and notice I've got to include that equal to 0. So it's greater than or equal to 0 along this portion, up to and including -3. And then it looks like it's greater than or equal to 0 on this little hill portion over here. Kind of looks like a hill to me. Because again, that's where it's above the x-axis, or it's allowed to touch the x-axis. Now, I have to simply describe those numbers. I have to describe those values that are on the x-axis. That's going to be my solution. So let's think about that first interval of numbers that I've got shaded in. How would I describe that interval of numbers? Because those are the x values, again, where I get an output that is either 0 or larger. So, well, if I look at that interval of numbers. Again, way out here is negative infinity. Well, to write that in interval notation, it says we'll go from negative infinity, so that's way out there. We go up to, and we include negative 3 because it's allowed to equal 0. And then we skip some stuff. And then it says the next place where we get something that's 0, we said that's when x equals 1. So that's when x equals 1. And then it says, okay, along this portion of the graph, all of the outputs are either 0 or larger, and that corresponds to this interval of x values. So it looks like we start at 1, and we go up to, and we include 6. Up to and including 6, so I'm going to include that also in brackets. Now notice we skipped a little bit in between, so what we do is we put this little, it looks like a U, that's our union symbol. That's going to be our solution set. And again, I'm going a little slow here, just hopefully so that it makes sense, because then we can go faster later. Okay, so that's going to be the solution set to that inequality. Now, what would change here if we go to the next one? Let's think about f of x greater than 0. Now we want to look at those values of x that are strictly above the x-axis. So the only thing that would change in our solution set, we simply can't include that value of negative 3, we can't include that value of 1, and we can't include that value of 6 because that's where it equals 0. And it has to be, well, strictly bigger than that. So we'll simply leave those values out. So in this case, our solution would be, well, still from negative infinity, but now we have to leave negative 3 out. So the notation we use is parentheses. And the same thing, we leave 1 and we leave 6 out, but we capture everything in between, so we'll use parentheses. And again, I have my union symbol. Now, f of x less than or equal to 0, that says where does the graph touch the x-axis, or where is it below? That's what it says to me. That's where I get my solution. It says look where the graph is either touching the x-axis or below. Well, it touches the x-axis here. Let's try a different color. It touches the x-axis here, and then it's below, below. And then it touches. Okay, then we have to skip, but here it touches, and again below. So those are going to be the sections. And I'm just thinking, what are the corresponding x-coordinates? Well, the corresponding x-coordinates, if I shade, would be from negative 3 up to and including 1. And then it looks like it's 6, and it just keeps on going forever and ever and ever. So I have to describe those two intervals. Well, I think I can hopefully do that. So that first interval, it says we start at negative 3 and we include it. And then we go up to 1 and we include everything in between. So we'll write it from negative 3 to 1, and then we'll put our union symbol because we have to skip. And then we said we jump to 6, and then we just keep going forever and ever and ever. So that means we go off to infinity, and we'll put our parentheses. So that would be our solution. Okay. All right, so I think we're getting there. And notice the same thing for number 4. The only thing we have to leave out there is where it equals 0, right? We have to leave out where it equals 0 because we want it to be strictly less than. So if it's going to be, if we want to know where our function is less than 0, it says look below the x-axis is what it says to me. That's what I'm doing. That's what it says to me. It says look where the graph is below the x-axis. Think about the corresponding x values. Again, that's where it's below the x-axis. That's where it's below the x-axis. I'm going to think about the corresponding x values. Let me try to erase this a little bit. Okay, that looks good. So it says let's think about the corresponding x values. Well, it would be from here. We don't include negative 3. Likewise, we won't include 1 because it has to be strictly less than. So notice, just like the between 1 and 2, all we did was drop. We just basically lost the brackets and went to parentheses. That's the same thing that's going to happen from 3 to 4. We're just going to end up dropping those brackets and having to replace it with parentheses. So we'll go from -3 up to 1, union, parentheses now around 6, and the infinity we leave alone. Last but not least, we didn't even talk about this. Well, we briefly. Where does it equal 0? And again, those are just the x-intercepts. So this would be at -3, at 1, and at 6. Right? So at -3, at 1, and at 6. So what am I trying to say is, what I'm trying to say is, if you have a good graph, you can answer the solutions. You can produce the solutions to these inequalities. Now suppose my graph doesn't look like this curvy graph. What if I give you a different graph? You would do the exact same thing. Well, suppose our graph happens to look like this. Okay, so now my graph looks like this. It looks like this U shape. Well, the same thing, if I want to figure out where that inequality is greater than 0, I would look at this little section of graph. Again, it's where it's above the x-axis. So I'm doing the same thing. Again, I wouldn't include that value, and then it looks like we would get this little section to the right. So if I think about those x values, there I am shading them along the x-axis. How would I describe that interval of numbers? Well, that first interval on the left that goes from -infinity, it looks like up to -1. We don't want to include it, though, because it's strictly greater than. And then to describe that second interval, we'll use our union sign. It says we start at 1 but don't include it, and then we just go off to infinity. It says those along these x values from 1 to infinity, if you take any x coordinate that's larger than 1, it says the corresponding y values are greater than 0. So that's going to be my solution set to that inequality. Okay, well, that's if we're just using f of x generically. What if we know a formula for f of x? Now, you may recall x squared looks like a parabola, and it happens to be sitting right at the origin. And you may know that if you take 1 from that parabola, it just shifts it down 1 unit. Okay, so this is now the graph of, let's get rid of f of x here, because now I actually have a formula for it. Well, let's leave it there. I now have a formula for it, though. I know that f of x is equal to x squared minus 1. That's this graph. So instead of solving... originally we just solved, we said that f of x is greater than 0. We said that that was on the interval from -infinity up to -1, not including it, union from 1 to infinity. Well, now likewise we've solved equivalently. We've solved x squared minus 1 greater than 0. We've solved this. We know where x squared minus 1 is greater than 0. It does it on this interval. Right? We just said, okay, there was f of x generically. Now I've just given it a name. So x squared minus 1, that's this graph. We said its y values are going to be larger than 0. On this section of the graph, put an open circle. And on this section of the graph, and again, I'm just thinking about those corresponding x coordinates. All right, if you can... if that makes sense, how to find out, how to solve. So really this is the important part, I think, of what I'm saying is, can you find solutions to these inequalities and also one equation if you're given a good graph? If this makes sense, then everything that follows is really just going to bounce off of this. So this is the key idea. So if you understand that, you're good to go. Now we're just going to get into the technical details. So again, this is the moral of the story, what I'm trying to say. You can get a solution to those inequalities by producing a good graph. A good graph. Good graph. Okay. So let's play Can You Graph? Because really that's all it comes down to now, solving these quadratic inequalities, is being able to graph them. That's one way to do it. Either that or algebra. Okay, so let's talk about graphing quadratic functions. Because once you graph the quadratic function, you can answer, you can find the solution to the inequality. Okay, so this is what I said a second ago. If all that made sense, we're good to go. So all I'm going to do is graph these things, and I'm going to do it in one of two ways. The first way I'm going to do it is using a calculator or a computer program or something, right? I'm not graphing it by hand. I'm going to use some sort of technology. And if you can, if you have that option available, this is great because that inequality is just going to turn into, where did it go? It's just going to turn into one of these questions. You're going to spit out a graph and you'll be able to answer the inequality from that. Okay, so that's nice if you're allowed to have a graph. The other way that I'm going to do it is simply by finding x and y intercepts, and then again I'm going to think about what's going on with the quadratic, and that's going to give me a way to answer these. Okay, so let's suppose I was asked to solve this inequality x squared plus 2x minus 3 greater than 0. Well, all I've done, you can see my graph here. I went to Desmos. Shout out to Desmos. If you've never been on Desmos, it's a great free graphing utility. All I did was type this in, and I said graph it, and it spit out this nice pretty graph on the right that we're using. So check it out if you've never used it. It's definitely a resource I use. Okay, so if we want to solve x squared plus 2x minus 3 greater than 0, I went to Desmos, I graphed it, and it spit out this nice graph. And if you want to on Desmos, you can have it label these x-intercepts. So it turns out this is the x-intercept of -3, and this is the x-intercept of +1. And now I'm just doing what I said, what we did a second ago. I'm thinking, where is the graph above the x-axis? What are those x-coordinates? It's above the x-axis here. It's above the x-axis here. What are those corresponding y values? Or excuse me, what are the corresponding x values, oh my goodness, that go with those y values? The corresponding x values would be shaded to the left, shaded to the right. Notice I'm using open circles because, again, it's strictly greater than. So to describe that using interval notation, that would be from -infinity, it looks like up to -3. We'll put our union sign, and then from 1 to infinity. Suppose I want to figure out where x squared minus 2x plus 1 is less than or equal to 0. Well, there's my nice graph of x squared minus 2x plus 1. Now notice it just touches the x-axis at x equals -1. So this inequality, though, to me it says look either below the x-axis, either below or touching, I should say. Below or touching the x-axis. I'm looking for sections of graph that do that. Look for portions of a graph that are below or touching the x-axis. Well, there's nothing below. The only thing that's touching is right there at x equals 1. So that would be my solution in this case. There's only a single point, x equals 1. So we don't need this interval stuff. It was correct for our previous example, but what I'm saying is we don't need that interval for our second one because we only have a single point that works. Suppose I've got another inequality. Suppose it says, where is -x squared plus x minus 1? Where is that greater than or equal to 0? Well, again, I said, hey, Desmos, will you graph -x squared plus x minus 1? And it said, no problem, and it gave me this parabola. Notice that the coefficient in front of x squared is negative, and recall that's when your parabola is going to open downwards. Okay, so that's something to recall. Now, this inequality says, it basically says, where is the graph greater than or equal to 0? Well, if it's greater than or equal to 0, that means where is the graph above the x-axis? Well, if this is the x-axis, right, where is the graph above the x-axis? I think we would say nowhere. right? It's simply not above the x-axis. So the solution, we would say, well, there are no solutions. You could either say no solutions. You could give the empty set. That would be another way to do it. Typically in an algebra or an algebra pre-calculus, calculus, if they said solve this inequality, I would just simply say there's no real solutions. No solutions that work, and that should be satisfactory. So again, right, if you have a graph, it's not too bad, as long as you just recognize either, hey, I'm either looking above the x-axis or I'm looking below the x-axis. And the only thing you have to think about is, is it less than or equal to, greater than or equal to? And then you just need to include that place where it touches the x-axis, or you don't. You just have to include that. Okay, so again, a graph to me is relatively straightforward. Let's talk about a little bit. So now we're going to start bringing a little bit of algebra into it. Suppose we don't have the graph. So this is where we no longer have the graph. So maybe, your instructor says, no calculators, no technology. You got to do this, quote unquote, by hand. Okay, no problem. That's no problem. I'm still thinking about the graph, though. So the question really now turns into, can you find x-intercepts? One thing I want to point out, I haven't quite addressed it yet. Notice in my inequalities so far, one side of the inequality has always been 0. That is crucial, okay? Just like an equation, one side has to be 0. I'll have a couple examples, or at least one where I don't. You have to turn it into a form where one side is 0. So do be aware of that. It's no accident that my examples have been set up with 0 on one side. Okay, so I'm still thinking about it in terms of the graph. X squared plus 2x minus 3, maybe I don't know the graph of it, but I can find x-intercepts to graph that. So what I'm going to do is I'm going to solve the corresponding equation, x squared plus 2x minus 3 equals 0. So again, I want to solve this inequality. That's my goal, but I'm going to use this equation first. Well, to solve the equations, I do one of two things. I either try to factor it, or I'm going to use the quadratic formula. That's all I do. I think this one I can factor, because I need two numbers that multiply to -3, but add up to +2. Well, I think I could use x plus 3 and x minus 1. Does that look okay? I think it looks okay. And recall, we take each factor and we set it equal to 0. So x plus 3 equals 0. I could subtract 3 from both sides. That would give me x equals -3. So again, just in terms of the algebra, subtract 3, subtract 3. That'll give you x equals -3. Then I take my second factor, x minus 1 equals 0. We could add 1 to both sides, and that would give me x equals 1. Okay, now this is where I don't have to do much more, okay, if I want to solve this inequality, because now I'm thinking about a couple things. I've got my x-intercepts. I know it's at -3 and it's at +1. That's what I just found. But this is where I do this other thing. I think about, is the graph opening upwards or is the graph opening downwards at this point? Well, if I think about this, if I think about x squared plus 2x minus 3, so if I think about y equals x squared plus 2x minus 3, the leading coefficient is +1. And since it's +1, I know that my graph has to open upwards. So the only thing that could happen is this graph looks something like this. I don't know how far it goes down, right? My graph could go way far down. So that's a poor looking graph, but all I know is that it's opening upwards because of that leading coefficient. So if it opens upwards, that's a rough enough of a graph for me to answer this question, because it says, again, if it has to be greater than 0, right? Greater than 0 says above x-axis. Well, from this, I could now get my solution. It would be above the x-axis here, which would be this interval of numbers. We don't include negative 3. So that would be from negative infinity up to negative 3. And then I would include, I would jump and I would go to 1, but not include it, and then go forever and ever and ever. Okay, so I'm still thinking about a graph. I'm just finding x-intercepts, and then I'm thinking about, does it open up or down? And that's going to give me enough information. So the same thing, let's figure out where x squared minus 2x plus 1 is less than or equal to 0. Well, I would solve that equation, x squared minus 2x plus 1 equals 0. Now notice this factors actually as x minus 1 multiplied by x minus 1. Because I need two numbers that multiply to positive 1 but add up to negative 2. Well, negative 1 and negative 1 would do that. Well, if I take x minus 1 and set it equal to 0, I could add 1 to both sides. And that would give me x equals 1. Now notice, in this case, I've only got one place where it touches the x-axis, and that's at positive 1. That's fine. That's no problem. That's okay. It's allowed to just touch the x-axis. Now notice the leading coefficient again is going to be a positive 1. So I know that this thing is touching, but then it just opens upwards. It opens upwards. Well, less than or equal to 0, that means where does it touch? Again, where does it touch or below the x-axis? And we're talking again about the graph. That's what we're talking about. Where does the graph touch, or where is the graph below the x-axis? Well, simply at x equals 1. So again, our solution is going to be x equals 1. And notice, these two things that I'm doing without graphing, well, we really already had the graphs to them, right? We've already seen these. But this is the way I would be doing it without these graphs. So I'm still doing the same thing, just in my head now is what I'm doing. Now let's suppose we want to solve negative 3x squared less than 7 minus x. So this is, so this is good. This is like what I said a second ago. I need to make one side 0. There's a couple different ways we could do it. We could take the 7 minus x and move it to the other side carefully. We would have to change some things. What I'm going to do, though, I'm going to add my 3x squared to both sides. Because I want the coefficient on my x squared, I typically like for it to be positive when I either try to factor or use the quadratic formula. So now on the left side, I would just be left with 0. I'll write the positive 3x squared first. I'm going to write the minus x next, and then my plus 7 last. So that I've got 3x squared minus x plus 7 on the right side after some reordering. You could try to factor this. I don't think this is going to factor nicely. I'm not even going to mess with it. So instead, though, I still know I have to solve the corresponding equation. That's where I set it equal to 0. I'm going to use the quadratic formula is what I'm going to do. So remember the quadratic formula. It says we use x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And we can label in this case. A is the number in front of x squared. So a is going to be equal to positive 3. B is the number in front of x. You have to account for the sign. So our b value is going to be equal to negative 1. And it says our c value is going to be equal to positive 7. Okay. So it says we have negative b, which is negative negative 1, plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a, which is 3, times c, which is 7, all over 2 times a, which is 3. Now, one thing I want to point out here, if we simplify underneath the square root, I'm going to start simplifying here. So I'm already noticing something. So let's think about what negative 1 squared is. Well, that's negative 1 times negative 1. Negative 1 times negative 1. That's positive 1. Well, 4 times 3 times 7, what is that? 12. 4 times 3 is 12. 12 times 7, I do believe, is going to be 84. So now I've got 1 minus 84. Well, 1 minus 84, I could keep going. That's going to be negative 83. Now, I've got a negative number underneath a square root. And what this means is there's no solutions. And that means it doesn't cross. So there's no x-intercepts. So it doesn't touch the x-axis. Does not touch x-axis. Okay, well, let's think about what happens here. Now, let's think about the graph of 3x squared minus x plus 7. If it doesn't touch the x-axis, what could happen to the graph, right? So here's let's think about a graph here. Let's think about a graph here. And this one I just made up. I haven't even really done this one, so let's think about it here. So if the graph doesn't touch the x-axis, the leading coefficient, though, is a 3, so it has to open upwards. So what would happen? Well, it can't be down here, because if it opens upwards and it's down, eventually it's going to cross the x-axis. That doesn't happen. So I don't know where it's at, but I know that it has to be strictly above the x-axis, so my graph would look something like that. Well, for this inequality, it says, where is the graph above greater than 0? So this says this inequality says, where is the graph? Where is the graph above the x-axis? And it looks like the answer to that is everywhere. All right? So in this case, our solution, finally, to me it looks like our solution set would be just all real numbers. And you could write that in interval notation as from negative infinity to positive infinity. Okay, so interesting. All numbers work. Okay. Last but not least, let's solve 2x squared minus 5x plus 4 greater than 0. Again, I made this one up. We can use the quadratic formula again. I don't know what's going to happen. A equals 2, b equals negative 5, c equals 4. So we have x equals negative b, which is negative 5, plus or minus the square root of b squared, minus 4 times a, which is 2, times c, which is 4. I think the same thing going to happen here. It looks like it, over 2 times a, which is 2 times 2. So let's simplify. So negative 5 times negative 5, that's going to be 25. So let's see, 4 times 2 is 8. 8 times 4 is going to be 32. So, okay, it looks like the same thing is happening here in that I'm getting a negative number underneath the square root. 25 minus 32, that's going to be negative 7. Negative 7. So again, there's going to be no real solutions. So we know that it doesn't touch the x-axis. And again, since the leading coefficient on this is positive, we know that it has to open upwards. And again, it looks like to me, in this case, it says, where's the graph above the x-axis? Well, everywhere. So it says the solution, just like our last example, would be all real numbers. All right. So, alrighty, so again, I'm still doing the same thing. I'm just thinking about, I'm trying to find x-intercepts and then think about whether it opens up or down. Because if it does cross the x-axis, I can think about, where is it above? Where is it below? Where is it below based on whether the graph opens up or down? Or likewise, maybe it doesn't cross at all. But again, based on whether it opens up or down, I can then deduce where the graph is. And again, that's enough to answer it. Okay, so let's keep going. Whew, intermission time. So now we're going to do really almost the same thing. We're going to do We're going to solve these using some algebra, but again, I'm going to do the same idea. I'm going to find x-intercepts, but instead of thinking about the graph, suppose I have no clue about the graph, I'm going to use test points. And this is nice because this is something we can do in a more general setting, right? We are solving quadratics, but this works in general, so this is good stuff. Okay, x squared plus 2x minus 3 greater than 0. We solve that corresponding equation. Now we said this factors as x plus 3, x minus 1, and we got the solutions of negative 3 and x equals positive 1. So this is where the test points come into it. So this is kind of the new part now. So what I do is I take those numbers and I plug those on a number line. So there's negative 3 and there's positive 1. Now what I do is I take a number from each interval. So I take a point in between negative 3 and 1. I take a point to the left of negative 3 and a point to the right of positive 1. It doesn't matter what numbers you use, just don't use negative 3 and positive 1. So maybe I'll use x equals negative 10, maybe I'll use x equals 0, and maybe I'll use x equals positive 10. Those are going to be my test points now. So I am going to, let's get rid of this. So now I'm going to test those values. And I'm just going to test them in the inequality. That's all I'm doing. So I'm going to test, let's test them one at a time. Let's test x equals negative 10. So I'm going to plug it in here into the left side. I'm going to think is negative 10 squared plus 2 times negative 10 minus 3, is that greater than 0? Well, I think so, because we're going to get 100 minus 20 minus 3. Well, that's definitely going to be larger than 0. So negative 10 works. Well, negative 10 came from this interval of numbers. If negative 10 works, it means that every number over there actually works. So I'm going to shade it in. Notice negative 3 won't work because that's where it equals 0, but we want to get out numbers that are greater than 0. Likewise, you could test x equals 0. So if you test x equals 0, we would have 0 squared plus 2 times 0 minus 3. And I'm asking myself again, is that greater than 0? Well, no, because we'll get negative 3 on the left. That is not greater than 0. So no shading in the middle, because that value didn't work. And lastly, I could check x equals 10. Well, I would have 10 squared plus 2 times 10 minus 3. Again, I'm just plugging it into my inequality. That is greater than 0. So that interval of numbers would also work. And now I can shade it in. So I would say my solution set would be from negative infinity up to negative 3, union from 1 to infinity. And again, this is what we did. This came from our very first example. We did it with a graph. We did it by finding x-intercepts and thinking about the what this graph would have to look like. But again, suppose you had no idea that x squared plus 2x minus 3 looked like a parabola. This would work. So you don't need, what I'm saying is this is the benefit. You don't need to know what the graph looks like at all to do this method. So suppose we want to solve this inequality. Well, again, I just turn it into an equation. X squared minus 2x plus 1 equals 0. We saw that factored as x minus 1 times x minus 1. And we set our solution to that as x equals positive 1. So there's positive 1. And now I've got 2 intervals. I could take something less than 1. Maybe I'll test x equals 0. And something larger than 1. You could use 2. I like to use 10, just because typically that makes the arithmetic even easier, or a lot of times it'll be even clearer that it does or doesn't work. So notice that x equals 0. We would have 0 squared minus 2 times 0 plus 1. Is that less than or equal to 0 is my question? Well, 1 is not less than or equal to 0. So this interval does not work. Well, what if we plug in 10? Well, is 10 squared minus 2 times 10 plus 1, is that less than or equal to 0? So again, I'm just testing it in the inequality. Well, no, that's not going to be less than or equal to 0, so this interval also doesn't work. We know at 1 we do get 0, though, because that was what we did right here. So the only place where our graph is going to, our inequality is going to be less than or equal to 0 is going to be at that value of x equals 1. And again, that goes with our graph. Right, let's go back and look real quick. So now, again, that agrees with our graph. But again, we didn't do anything with a graph, right, to solve that. We didn't think about a graph at all to solve this. We just figured out where it equaled 0 and did test points. Okay, and again, the same thing, negative 3x squared plus 5x minus 1. I think I made this one up. Okay, so let's, we would have to solve. So negative 3x squared plus 5x minus 1 equals 0. Okay, so I would use the quadratic formula. So x equals negative b, which would be positive 5, plus or minus. So our b value will be 5. It says we take minus 4 times a, which is negative 3, times c, which is negative 1, all over 2 times a, which is negative 3. Okay, so I wish I had made something nicer, but I didn't. So what do we get underneath the square root? So 5 squared is 25. It looks like we have a negative times a negative times a negative, so I'm still going to get a negative. And then 4 times 3 times 1, that's going to be 12. This is all over 2 times negative 3, which is negative 6. So this is negative 5 plus or minus the square root of 25 minus 12 is 13, all over negative 6. Okay, so I'm going to erase some room here, give myself a little room. Okay, so it says this is going to equal 0 at negative 5 minus the square root of 13 over 6. That's going to be the smaller value, right, if you're subtracting the square root. And then I'm going to have another value of negative 5 plus the square root of 13 over negative 6. Oh my goodness. Those are not nice numbers, but that's okay. So now I'm really thinking, where, I just need to get some test values here. And I left off a negative. Did I leave out? I left off a negative over here. So let's be careful about that. And let's even be careful about the our signs here, actually. So that's negative, that's positive. Okay, so I'm just trying to make sure everything's okay. Let's try to compare these two values. So I'm trying to figure out the test points. So I've got negative 5 over negative 6 minus the square root of 13 over negative 6. Let's try to clean these values up a little bit, is what I'm going to do. So it looks like in the numerator on this left side, so I tried to pick a nasty one, and now I've confused myself. Okay, let's clean up the values. So let's clean up this number. So negative 5 minus the square root of 13 over negative 6. Notice you can multiply top and bottom by negative 1. And if you do that, that's going to make everything positive. So this is really 5 plus the square root of 13 over 6. So maybe my number line is incorrect. That's what was making me nervous over here. And then we also have negative 5 over negative 6. It should be okay, right? Am I losing my mind? Plus the square root of 13 over negative 6. Okay, so that is going to be 5 over 6 minus the square root of 13 over 6. So, okay, so this actually is a little tricky. So let's make sure we've got everything labeled correctly. Okay, so I've got these two numbers, and notice I could rewrite my first one as 5 over 6 plus the square root of 13 over 6. Okay, so let's see, we've got 5 over 6 minus the square root of 13 over 6. That's one number. And then we have 5 over 6 plus the square root of 13 over 6. Okay. So now we've got to take some test values. So again, this is what I would be doing without a calculator. If you peeked over at me, all of those negatives just made me nervous. Let's see, the square root of 13. Whoops. I'm even going to try to estimate the square root of 13 in my head, just so I have a better feel for this. Well, the square root of 9, right? The square root of 13 would be bigger than the square root of 9. And the square root of 9 is just going to be equal to 3. And the square root of 13 would also be less than the square root of 16. And the square root of 16 is just going to be equal to 4. So I know that the square root of 13 is somewhere between 3 and 4. So I'm trying to think if this number is going to be positive or negative still is what I'm thinking about. And it looks like this is still going to be a positive number. So 0 is actually over here somewhere. So I've got to take something in between. Oh my goodness. So, okay, so I know I could test x equals 0. I could also test x equals, let's test a number that's clearly larger. X equals 10. That's going to be from the interval on the right. So x equals 10 will fall in this interval. X equals 0 would fall in that interval. And you could test, let's test 0. So I would get, I'm going to test it here. Notice the first two terms would simply be equal to 0. 0 plus 0. And I know that negative 1 is not greater than 0. So this interval does not work. Likewise, if I test x equals 10, I would have negative 3 times 10 squared plus 5 times 10 minus 1. I think, is that greater than 0? And this is going to be negative 300. This is not going to work, so I know that this isn't going to work. We could figure out a value here after some arithmetic. You can actually show that this interval does work. So it looks like our solution set in this case would be the solution. Our solution set is going to be, let me try to give myself a little space. I would know that these values in the middle work. It's got to be strictly greater than 0, so we won't use these values. So it would be 5 minus the square root of 13 over 6 up to 5 plus the square root of 13 over 6. That would now be my solution set for that inequality. So again, that's how I would go through it, with quote-unquote nice numbers. So again, this last bit I think is useful because in general, suppose I said, solve this. X to the 5th plus 3x to the 3rd minus 4x greater than 0. This is a polynomial on the left side. So the idea when you have these polynomial inequalities, even if it's not quadratic, what we try to do is try to factor it, and then we can use test points because maybe you don't know what the graph of this looks like. Well, let's solve it. Okay, let's try to solve this. So again, what I would do is I would turn it into an equation. And is this the one I want? I think I need to change this. We'll see. I think this works out correctly. I may have copied it down wrong, so my apology. No, I think it's okay. So so in general, no matter what it is, the first thing I try to do is set it equal to 0 and factor. Now notice I could factor an x out. I would have x to the 4th plus 3x squared minus 4 left over. So now I would think, does this factor? And maybe you've seen factoring techniques for this. It's actually really, we could factor it just like a quadratic. So the answer is yes, this does factor. So I'm going to leave the x alone. This actually factors as x squared plus 4 multiplied by x squared minus 1 is how that's going to factor. And again, maybe you've seen this, maybe you haven't. That's not the point of this. The point that I'm trying to illustrate here is you can just keep trying to factor. Now, x squared plus 4 does not factor, but x squared minus 1 does factor. It's a difference of perfect squares. That's x plus 1 and x minus 1. This is now completely factored. If we take each of these factors and set it equal to 0 and solve, if we set x equal to 0, well, at x equals 0 at 0, there's nothing to do. If we take x squared plus 4 and set it equal to 0, well, we could subtract 4 from both sides, and then we could try taking the square root, but we can't take square roots of negative numbers. So this part, there's nothing that'll make that equal to 0. But then I would do the same thing. I would say, well, I would take x plus 1, set it equal to 0. I could subtract 1 from both sides, and that would give me x equals negative 1. And then I would do the same thing for the last one. I would add 1 to both sides, and I would get x equals positive 1. So now I've got all of the x-intercepts for that polynomial. Well, what would I do? I would now take test points, just like before. So something smaller than negative 1, maybe I could use x equals negative 2. Something between negative 1 and 0, maybe I could use x equals negative 1/2. Something between 0 and 1, maybe I could use x equals 1/2. And then something larger than 1, I'm going to use x equals 10. Speaking of which, I'm going to go backtrack and change that from negative 2 to negative 10. So I'll test 1 point. So you would have to test 1, 2, 3. You would have to test 4 points for the 1, 2, 3, 4 intervals. So notice, for example, maybe if I test, I'm going to test x equals 10. You could plug it in anywhere. You could plug it in at the bottom. You could plug it in at this level. You can plug it in anywhere because they're all equivalent. But I would plug in x equals 10, and again, I'm just thinking about that inequality. So is 10 to the 5th plus 3 times 10 to the 3rd minus 4 times 10. Do you think that's going to be greater than 0? Well, I definitely do. 10 to the 5th is good. That's going to be a very large number. So yes, that works. So that means that every number over here works. So when I go to put my solution set, now I don't know if this first interval works. I don't know if this interval works. I don't know if this interval works. I don't know if this interval works because I haven't checked those yet. But I know that starting at 1 and going to infinity, that's going to be included in the solution set. I know that's at least part of it. And you could go back and check x equals negative 10, x equals negative 1/2, and x equals 1/2 as well. So again, maybe you don't know what x to the 5th plus 3x to the 3rd minus 4x looks like. It's definitely not quadratic. But I can still do the same thing of figuring out x-intercepts and testing points. That is what I'm trying to get across here. Okay. Bonus prize. You didn't know there was going to be a bonus prize, but there is. And this is a nice bonus prize because, again, it goes back to the very original thing. Suppose somebody came up to you and said, solve this inequality. Sine of 4x plus x squared minus cosine of 3x greater than 0. Now, sine and cosine, these have to do with trigonometry, with trig functions. Maybe you have no idea what that means yet. That's just fine as long as you can produce a graph. I, again, produced a graph, and there is the graph of sine of 4x plus x squared minus cosine of 3x. I've got it graphed here, or at least portion of it. Because really all I care about is where is it above the x-axis and where is it below the x-axis. That's usually what I'm interested in. Well, it turns out there's only 2 places where this graph touches the x-axis. It touches the x-axis at this point, which is that xy coordinate, and it touches at this point, which is this xy coordinate. Whoops, I think I boxed in too much there. This xy coordinate. Again, I want it to be greater than 0. Well, greater than 0 means I need to look where the graph is above the x-axis, strictly above the x-axis. So open circle here, open circle here. Well, it's above the x-axis. I don't know. It does something there, and it keeps going. So what x-coordinates are those? Those are the x-coordinates that start again here and go to the left forever and ever and ever, and here and go to the right forever and ever and ever and ever. Well, I can now write that solution set. This is negative infinity. So it says we go from negative infinity up to, well, that x-coordinate, which is negative 0, what is it, negative 0.1, negative 0.61237. And then we skip over these middle values. So we'll put our little union sign. And then it says we start again at this x-coordinate of 0.21397. And this just goes forever and ever and ever off to infinity. So that would now be the solution set for that inequality. Again, a good graph makes all of this really nice. So even when we didn't have a graph, I was still thinking about what a quadratic looks like. That helped me. And then when I didn't know the graph, I said, I can still do the same thing. I can figure out those x-intercepts and think about using test points, and that'll still do it for me. So it is tedious. Inequalities are tedious. There's no like real shortcut other than to do this stuff about figuring out x-intercepts. If you got a lot of x-intercepts, you're going to get a lot of intervals, and then you're going to have a lot of points to test. That is, unfortunately, kind of a downside of inequalities, but the good side is the good thing is it's just arithmetic at that point. You're just plugging points in and just seeing if they satisfy the inequality or not. So, again, a long video, a lot of information in this, but if you can get through this video and everything in this makes sense, you are in great shape in regards to solving quadratic inequalities and even better inequalities in general. The main thing I want you to take away from it, be able to do it from a graph. If not, factor, find x-intercepts, use test points. All right. Whew. All right, my friends, I hope this helps.